Let's be real, in a world that's always on, your application can't afford to take a break. So what happens when its heart, the database, just stops? Today, we're going to dive into how MongoDB solves this exact problem with a really slick feature called replication. So picture this. It's 3 a.m. Your phone starts blowing up. The one and only database server you have is totally unresponsive. Your app is down, users are seeing errors, and every second of downtime is costing you. What's the plan? For a lot of folks, the plan is just panic. And that whole nightmare scenario, it really boils down to one fundamental issue: the high availability problem. The logic here is kind of brutally simple, right? If you put all your eggs in one basket and that basket drops, well, you've got no eggs. A single database server is exactly that, a single point of failure. It has no backup, no safety net, and in a world that expects 100% uptime, that's a gamble you just can't take. So, how do we build that safety net?
Well, MongoDB's answer to this is both really elegant and super powerful. It's something called a replica set.
But before we get into the MongoDB specifics, let's just step back for a second. What's the core idea? If having just one of something critical is so dangerous, what's the most obvious way to fix it?
The answer is pretty intuitive. You make copies. And in the database world, we have a name for that. It's called replication. It's this simple, powerful idea of keeping identical copies of your data on totally separate servers. So if one of them goes down, another one is ready to jump in and take its place.
So MongoDB's replica set takes this basic idea and, honestly, puts it on steroids. It's not just a bunch of mindless copies. Think of it more like an intelligent, self-managing team of database servers. They all hold the exact same data, and they're constantly talking to each other to stay perfectly in sync and, crucially, to handle failures all on their own.
Now, like any good team, not everyone does the exact same job. The members of a replica set have very clear, very important roles to play. So you're probably wondering, how does this all work? Who's the boss? Who's just following orders? Understanding these roles is really the key to getting why replica sets are so powerful. Okay, here's the breakdown. In every replica set, there is one and only one primary node. This is the leader. It's the boss. Every single write operation and the insert, update, or delete has to go through the primary. This makes sure there's always a single source of truth. Everyone else on the team, they're secondaries. They're the backups, and their job is to keep a perfect, live, read-only copy of whatever the primary is doing. They provide that critical safety net, and as a bonus, they can also help out with read requests. But how do the backups know what the leader is doing? Well, the secret sauce here is something called the operations log, or oplog for short. You can think of it like a super detailed diary that the primary keeps. Every single change it makes gets written down in this log.
And the process is just running constantly in the background. A write comes in and hits the primary applies that change, and then immediately jots it down in its oplog. Meanwhile, the secondary nodes are basically just watching that log like a hawk. The second a new entry appears, they grab it and apply the exact same change to their own data. That's how they stay in sync, almost in real time.
Okay, so this all sounds great in theory, but how does it actually work in practice? Let's take a quick look at what it takes to get one of these replica sets up and running. Without getting lost in the weeds of every single command, the process is actually surprisingly simple. You basically just start up 3 separate MongoDB servers, and you tell them, hey, you're all on the same team. Then you connect to one of them, run a single command to say you're the leader, and then you just add the other 2 to the club. That's pretty much it. They start talking and syncing up automatically.
This is a fantastic question, and one that everybody asks. The gears in your head are probably turning. Hey, I've got these extra servers just sitting there with all my data. Seems like a waste not to use them for some of my app's read queries, right? Well, if you try it, you're going to get smacked with this error right away. See, by default, MongoDB is super cautious because replication takes a tiny fraction of a second. A secondary could be milliseconds behind the primary. To make absolutely sure your app never reads stale data by accident, MongoDB forces all reads to go to the primary by default.
But what if for some of your queries, reading data that's a tiny bit old is totally fine? Well, the fix is incredibly easy. You just run this simple command, rs.slaveOk. It's basically you telling MongoDB, hey, I get it, I know the risks, and for what I'm doing right now, it's okay to read from a backup. This lets you intelligently spread out your read traffic, which is a huge win for scaling.
Okay, so we've built our team, we know their roles, we know how they talk to each other. Now for the final exam. Let's go all the way back to that 3 a.m. server crash and see how our new replica set handles the pressure.
So this is the moment of truth. What happens now? The leader of our database team, the only server that can take writes, just vanished. Is it game over? Does our application go down with it?
The instant that primary server goes offline, it stops sending out its regular little "I'm okay" signal, its heartbeat, to the rest of the team. The secondary nodes pretty quickly notice that their leader has gone completely silent.
And this is where the magic happens. The secondaries don't just sit around waiting. They immediately call for an election. They all start talking to each other, comparing notes on who has the most up-to-date data, and they hold a vote to pick a new leader from among themselves. And within seconds, a winner is declared. One of the servers that used to be a secondary gets a promotion. It switches its role from a read-only backup to the new write-ready primary, and it's immediately ready to start taking over. And here's the punchline. This entire process, the failure, the election, the promotion, it all happens automatically, usually in just a few seconds. Your application might see a tiny blip where it can't write, but it never goes completely offline. That is high availability in action. It's not something you have to manage, it's just built in.
So let's just boil this all down. First, replication is all about creating redundant copies of your data for safety. Second, a MongoDB replica set is like a database team, with one primary handling writes and a bunch of secondaries acting as backups. And finally, the most important part, if that primary fails, an election happens automatically and a new primary takes over, keeping your app online.
If this explainer helped clear things up for you, do me a favor and hit that like button, share it, and subscribe for more. Now you know how to keep your database from going down. But what happens when your data gets too big for just one server? We'll tackle that next time. Thanks for watching.